This talk is Exploiting Windows Group Policy for Reconnaissance and Attack by Darren Mar-Elia. We have a few announcements before we begin. We'd like to thank our sponsors for Critical Stack and Ball Mail, and our stellar sponsors, Robinhood, Secure Code Warrior, and Paranoid. It's their support, along with our other sponsors and donors and volunteers, that make this event possible. We do ask that you please, these talks are being streamed live, so as a courtesy to our speakers and the audience, we ask that you check to make sure your cell phones are set to silent. If you have any questions, we will use the audience mic after the talk so that YouTubers can hear the questions and the answers. So after, just please raise your hand and I'll bring the mic to you.
Thank you.
Thank you.
How's everyone doing?
Good.
Well, I really appreciate the turnout for such a topic as group policy. I've been speaking for about 20 years, mostly at IT conferences, but this is my first time at BSides, so I'm super happy to be here. How many of you are reasonably familiar with group policy? Awesome. So I won't spend a ton of time talking about kind of the guts of group policy, although I think it's worthwhile to kind of review it just to make sure we're all on the same page. I guess questions are at the end, so if you do have questions as I'm talking, try to remember them, write them down or something, and I'll make sure I leave time for questions afterwards. A little bit about me. My day job is head of product at a company called Semperis. We do Active Directory protection and disaster recovery. I founded a website that many of you may have visited in your travels called gpoguy.com back in like 2004. And a company called SDM Software that sort of created commercial group policy, still does create commercial group policy software. I was a 14-time Microsoft Group Policy MVP until Microsoft summarily executed all group policy MVPs last year. So the reign of group policy MVPs has come to an end. There wasn't enough cloudiness in group policy for Microsoft's tastes. So they got rid of a whole swath of MVPs, including myself. Spent a bunch of years of my career, probably half of my career, in kind of enterprise IT for financial services and software companies. I have a group policy training course out on Pluralsight. I've got some projects out on GitHub. As the pictures sort of indicate, I have two incongruous hobbies of bike racing and making wine that I try not to mix. But that's what I do for fun for the most part. And let's see if I can make PowerPoint do what I want. So just a little bit of what we're going to talk about, just a little bit of a review on what group policy is, does, how it works. Some of the reconnaissance benefits of group policy, benefits in quote. Attacking group policy, what are some of the things that attackers can do with group policy? And then a little bit on defending against that. So what is group policy? Built-in configuration management technology for Windows and Active Directory, a roadmap to an organization's security posture, Windows security posture, a malware delivery vehicle, or all of the above. Can anyone guess which answer is correct? Right. Actually, just kind of interestingly, the last time I was at BSides here was in 2016. So at that time, I had been 17 years working with Active Directory and group policy, blissfully ignorant as to the threats against both Active Directory and group policy. And I sat in a room just like this and listened to a talk about Bloodhound. How many of you are familiar with Bloodhound? Yeah, it's an amazing tool. And my eyes were opened. And I started to think about how group policy would benefit or not benefit from the same kinds of approaches that the guys were doing with Bloodhound. And actually, after the original release of Bloodhound, they released kind of a GPO release that had a bunch of discovery in it, which I'll talk about in a little bit. But it sort of got me thinking about this whole notion of group policy from a security angle. And that was kind of my my path to where I got to today, where I'm talking about group policy and security. I have a mailing list that's got something like 17,000 people on it, and every couple of years or so I do a survey to try to understand what people are doing with group policy, how it's changing. Is everyone mass migrating to Intune because it's so awesome? Stuff like that. And one of the things I ask is, how are you using group policy? And this is useful to sort of understand what let's say the attack surface looks like. In most organizations, group policy is used for 80+% for general administrative templates lockdown. Security, hardening, and general kind of registry tweaks, just under 80%. And then, other parts of group policy come in here. Drive and printer mapping is pretty high, folder redirection, browser configuration. All of this stuff is, plus 50% in most organizations. So it's worthwhile to know that if you're in a position of using group policy to secure your environment, this talk is very relevant to you, and it's also very relevant to an attacker that's looking to exploit group policy to worm their way into your environment. So just about the structure of GPOs, because I think it's important when we're thinking about abusing group policy. There's a lot of words on this page, but basically there's two sides to a group policy object. This is the way Microsoft architected it from the beginning, for better or for worse. There's a piece in AD that's called the GPC. It's in the CN equals policies, CN equals system container. You'll see a bunch of GUID named containers. You can kind of see it on that screenshot. Each one of those GUID named containers represents one GPO. And on that GUID named container are a set of attributes that talk about the friendly name of the GPO, the path to the other side of the GPO, the version number of the GPO, information that we'll talk about a little bit more that's relevant to how group policy functions. As I implied, the other side of the group policy object is called the group policy template, or GPT. That's in sysvol. Now, this was a huge problem in the early days of Windows 2000 and Windows 2003 because Microsoft had this really wonky mechanism called FRS that would replicate sysvol to every domain controller, sometimes. And so you'd have this situation where you'd make a change to a GPO and the AD side would be changed, but the sysvol side wouldn't replicate. So the clients would think that something has changed in the GPO, but didn't really get the new settings. And it was a cause of a lot of consternation. They now have FRS that is more robust and allows sysvol to be more consistent across all the DCs. Now you still have some latency and some difference in replication between the AD part of the GPO. Did I say FRS? I meant DFSR. The AD part of the GPO and the sysvol part of the GPO, they're not going to replicate identically at the same time, but such is life. It's a best effort sort of scenario in that case. But the point is, you have these two pieces of the GPO that are supposed to be synchronized from the perspective of permissions and content. So if you edit a GPO, by default, when you edit a GPO, it's targeting the PDC emulator domain controller in your domain. When that happens, the change is made to the AD side, the change is made to the sysvol side, and then it replicates out from there. That's the way it's supposed to work. The other thing to know about the GPT, this is where most of the settings storage occurs. So when you're defining an admin template setting or a GP preferences drive mapping or a security hardening setting, it's getting written to files in sysvol. Now there's a few exceptions to that. One is software installation. Software installation is a part of group policy not terribly used anymore, where you can deploy MSI files. That particular area writes a piece to AD and a piece to sysvol. So it's kind of split between the two. Okay, so why am I talking about this? So the point about it is, and we'll get into it in a little bit, both sides of the GPO you have to pay attention to both sides from an attack perspective, because attackers can take advantage of inconsistencies on either side, mostly in delegation, to put stuff into group policy objects that shouldn't be there. So when we talk about processing of group policy, it is strictly a client-side operation, meaning that if it's Windows Server, Windows Desktop, Windows Workstation, it is doing the work of pulling down the group policy. So when it does that, it does it in two phases. The first phase is basically, tell me all the GPOs that apply to me. That's called core. The core phase gets done. And it queries AD, uses LDAP, determines which GPOs apply to it. It's got its list. And then it says, OK, I know which GPOs apply. I know which policy areas are in each of those GPO. So then I'm going to call the client-side extensions, or CSEs, to bring each, to basically by policy area, bring down the setting storage for each GPO and process it, do whatever it says. Map a drive, make a registry setting, change a security configuration, SAM, whatever it happens to be. The CSE is responsible for actually processing the policy. That's a DLL, sits in System 32. Microsoft ships a bunch of CSEs out of the box. A little known fact, this is an extensible framework. It was meant to be an extensible framework from the very beginning. There are third-party vendors that have extended group policy. Essentially what that means is writing a new CSE and writing a new MMC snap-in to the GP editor to be able to set those settings. But you can do it. A little C++ knowledge and the ability to register the CSE in the registry. You need to be an admin to be able to register a new CSE. But if you are an admin, you can register that CSE and you can provide new policy functionality. So I went through that. Settings are per computer or per user. But in either case, as of MS 16072, I think, when per user policy processing runs, it runs in the context of the machine account local system, and then it will impersonate the user to make the user-specific changes. The reason they made that change was for, I don't recall the exact scenario now, but there were some man-in-the-middle attacks on group policy processing that were taking advantage of the fact that GP processing for the user was running in the user context. So they moved GP processing for the user into the user context. They broke a whole bunch of IT shops in one fell swoop because when you rolled out this MS 16072, all of the GPOs that you had filtered by user security groups didn't work anymore because you had to grant the computer access to that GPO in addition to the user group. More detail than is useful at this point, but just wanted to set that context. GPOs get refreshed on clients and member servers every 90 minutes by default, plus a 30-minute randomizer. So it could be 90, it could be 120, or anywhere in between. Now, why this is important, and it's 5 minutes on domain controllers. Why this is important is that if somebody futzes with a GPO thinking that it's going to have an immediate effect, it doesn't. In a large enough organization with sufficient randomization, you probably have machines that are refreshing group policy all the time. But the point here is that it's not going to be instantaneous across the organization when you make a change to a GPO. So targeting. So you have a GPO. You create a GPO in AD. It does nothing until you link it to something. You link it to a site, an AD site, which is just a collection of IP subnet definitions in AD. You link it to a domain, to the domain at the domain NC head, which is the top level of AD. Or you link it to an OU, or organizational unit. Once that's done, all other things being equal, you will start applying that GPO to computers and users in AD. And there's an order of precedence to that. On Windows, on every Windows SKU, server or workstation, there's a local GPO. There's actually something called multiple local GPOs that they introduced in Vista, which is probably an area for exploit, but I haven't really dug into it too much. But the point is that there is this concept of a local GPO that you can edit just on that machine to set policy. It will be overridden by any site link GPOs if there's conflict, by any domain-linked GPOs, and then by any OU-linked GPOs. So you have this order of inheritance with group policy, site, local, site, domain, OU, where you could have 10 different policies applying to a given computer account, and if there's conflicts along the way, the last writer wins, meaning the OU-linked ones win. Now, there are two things you can do to disrupt that. You can set a link higher up, let's say at the site level, to enforced. That will always win over a conflicting setting set at the OU level. You can, at the OU level, you can block inheritance. Block inheritance says everything above me in the order of precedence, ignore it. The enforced link wins out over block inheritance. So enforced wins in every situation. That's useful to know both as an attacker and as a defender, because if you're an attacker and you're able to write GPO links, what are you going to do with that link? You're going to make it enforced, because it will beat out everything that somebody tries to do to circumvent you down below. And then there's also, on a given OU, you can have 10, 15, 20 GPOs linked. There's an order of precedence in those as you're looking into tooling, and I'll show you this in a little bit. So you've got linking, but maybe you want to get more granular about who in the OU you want that policy to apply to. You have a number of different filtering criteria. You have security groups that you can use. You can say on the GPO, only apply this to members of the marketing users group in the marketing OU. You have WMI filters that you can attach to a GPO. You have one WMI filter per GPO. A WMI filter is a WMI query that gets executed by the client. If it's true, the GPO applies. If it's false, it doesn't. The WMI query is used for things like only apply this to Windows 7 machines or Windows 10 machines. And then you have GP preferences, which is a section of group policy, and I'll show this so it kind of becomes real. In each of the GP preferences areas, you have something called item level targeting, where you can have filtering on a per setting basis. If it's any wonder why people hate group policy, this slide captures it beautifully. It is super complex. And that complexity is both a blessing and a curse, because it gives you a lot of flexibility, but it gives attackers lots of surface area to go mess around. This last point is important. Group policy is normally only updated on the client if something in AD has changed. In other words, if the GPO is updated, it gets a new version number. The client wakes up for its group policy processing cycle and says, the last version I processed is 2. What is the version on the GPO? It looks in AD for the version. It ignores sysvol, which there's a version there, but it doesn't get updated anymore. It's only looking at AD. If it says 2 on AD, it doesn't process the GPO that time around. It just ignores it. So if somebody has tinkered with the GPO but hasn't messed with the version number, it's not going to pick up that tinkering. That's important. Now, there are ways to circumvent that on a per CSE basis, but for all other things being equal, you can, if the version numbers are the same on client and AD, the GPO is ignored during that cycle. Let me, before I move on, I want to just talk a little bit, or show a little bit of this stuff so that it's not so abstract. I mean, I'm sure most of you have messed around with this, so I'm not telling you anything that you don't know. But here's my domain, testme.net. I have one GPO linked at the domain level. I have all these nifty OUs. You can see the GPOs that are linked at the client's OU, for example. I have 3 of them. The one at the top of the list gets processed last, so it wins if it's conflicting with any of its other ones. If there's conflicts between the default domain policy and any of these, then these guys win because they're lower in the pecking order. Last writer wins. If I come down to the AD site, I have actually no GPOs linked at the AD site, but if I had a GPO linked here, it would be processed first or after the local GPO on that particular client. And so it would, if there was conflicts between it and the domain or the OU, the site linked one would lose. Now if I dig into a particular GPO, I've got the computer side and the user side. Pretty straightforward. We have policies and preferences. When I was talking about item level targeting on preferences, if I create a preference, let's just do something kind of simple. I'm going to say C:, oops. I'll just do just enough to get me into this. You can see what item level targeting looks like. On that particular setting, I now have 27 different possible types of targeting I can do in ANDed and ORed combinations if I choose to do so to further filter that GPO. So lots of opportunity here for confusion. So that's kind of a review of what I just talked about. Let me just quickly, so you can kind of see what I'm talking about. Here's the GPC, right? This is the AD part, the group policy container part. Each one of these GUID folders represents a GPO. If I come into the properties of that and look at the attribute editor, you will see the display name of the GPO, you'll see the GUID of the GPO, the distinguished name. You will see, if I come all the way down to the end, the version number. That is the version number of the GPO that the client looks at when it's trying to determine if anything has changed. And I'll refer to this in a little bit. There's also these two attributes called just GPC and GPC machine extension names and GPC user extension names. These hold the GUIDs of the policy areas implemented in this GPO. This is super important when it comes time to talking about tinkering with group policy setting storage. These GUIDs have to exist for the corresponding policy areas that are in the GPO, or the client will simply ignore it. And not only do they have to exist in the GPC, they have to be sorted alphanumerically. So I've had some people kind of talk to me about, injecting settings into group policy objects, and they're able to do it, but they can't figure out why it's not working on the client. This tends to be the reason why. The GUID's not the GUID, it's actually a pair of GUIDs are not there for that particular policy area, and they're not sorted. Maybe they're there. I discovered this early on. Maybe they're there, but if they're not sorted, they're also ignored by the client. So there's a very precise kind of way of messing with group policy that you sort of have to be aware of as an attacker or even as a defender, frankly. Okay. Let me get back into this deck. So why is GP useful for reconnaissance? Well, as I indicated in that little survey that I showed, many IT shops are using it for security hardening. A lot of the baselines that you get from the standards bodies or from Microsoft, they come in the form of group policy object backups. They're basically telling you, use group policy for this. Of course, Microsoft has some other technology like SCCM that they offer for this, but most shops, it's free, it's in the box, it's generally well understood. They use group policy to do security hardening. And they're doing it for not necessarily an order of importance, but certainly close. Local group membership, like setting local administrators, configuring user rights, so who can do debug programs, who can do log on locally or log on access this computer from the network, who has remote desktop access to the computer. Those are user rights, control all that stuff. Security options like whether UAC, user account control, is enabled or not. All that's set in group policy. If you're using, how many of you are doing admin tiering? When, Microsoft talks about tier 0, tier 1, tier 2. Right, of those of you who are doing admin tiering, how many of you are implementing admin tiering enforcement through group policy? Yep, so roughly the same amount. So the ability to control who can log on to domain controllers, who can log on to servers and workstations. That's all implemented in group policy. Password policy. How many characters should the password be? How long should it last? Should it lock out? And then configuring local admin passwords used to be a feature in group policy preferences. How many of you used group policy preferences to configure local admin passwords? Surprisingly few. That's good. I've heard that this is still a problem when pen testers go into a Windows environment. They're finding these things littered all over the place. Why is it a problem? Well, because as part of Microsoft's protocol docs, they publish the encryption key for the policy storage in the doc. So, and it uses the same encryption key for every single implementation. So you can decrypt all of the passwords that are in group policy storage. And as I mentioned at the last point here, which is like the most important point for group policy as a reconnaissance tool, GPOs are world readable by default. Every authenticated user in the domain gets read access when a GPO gets created. To your security hardening, to your drive mapping, you know, the most trivial stuff and the most important stuff is world readable. If I'm on AD, if I'm authenticated to AD, which we now, you know, this day and age, it's not that tough to get a foothold in an environment, even as a non-privileged user. And as a non-privileged user, I can run Bloodhound, for example, and get a map of who's in which who's in admin groups on which machines. Or other tools will let me, you know, read the password out of GP preferences so that I can log on to a machine as admin. So this world readable thing is a blessing and a curse as well. So I wanted to kind of highlight some tools that are useful for reconnaissance of group policy. PowerView, it's part of PowerSploit. It's got a bunch of commandlets, PowerShell commandlets in there for enumerating admin access on machines by user. The new GPO immediate task is actually a kind of a working sample of being able to inject settings, in this case for a scheduled task, into a GP preference on an existing GPO. It assumes you have access, of course, but the point is with this commandlet you can do that. SharpHound, which is the ingester, the data collector for Bloodhound, collects a lot of the same information. You know, if you set it to run in that mode, using group policy, without hitting the DC, I can figure out who's local admin on a machine, or without hitting the machine itself. I think it's part of the so-called stealth mode to use group policy to determine who's an admin on which machines in the environment. And then Grouper 2 is my new favorite plaything. This is written by Loss. He's out in Perth in Australia. And it is super cool. If you haven't downloaded and tried Grouper 2, it is a great tool. I'll show you it in a minute, but it's basically what he's done is he's gone through and sort of come up with a list of things that represent a potential problem in group policy from a security perspective, everything from permissions on GPOs to local admins being added to GPOs to, you know, GP preferences, passwords being found in GPOs. And if you run Grouper 2 against your AD environment, it'll enumerate all of these, give it a risk score, or I think he calls it an interest level, and let you sort of assess in one fell swoop all of the potential issues that you have to be worried about from a group policy perspective. So let me I'm going to just drop in and show some of this stuff. All right, so I've got one just up on the screen here. This is a PowerView commandlet called find group policy GPO computer admin. I pass it a computer name and the domain name, and it tells me what policies are granting which users admin access or remote desktop access on this machine, this Win 10 client. So it's called out this group called Tier 2 admins, which is a member of local administrators. You can see here it's a group in this GPO, and it's using the GP preferences local users and groups feature to grant that access. This one is domain users being granted remote desktop users access in this GPO using restricted groups policy. So it's really great at kind of calling out for a given machine, or I can flip it around and ask for a particular user, where does this user have admin access? Now this is a fairly simple environment, but you can imagine if you're an attacker trying to get access to this information, running it across an entire environment, you're going to get a lot of good information. Now, a common thread for all of these tools is you don't require, the person running the tool doesn't require GPMC. That's been kind of a stumbling block for most, I don't know if I'd call it a stumbling block, but it was a hurdle for any tools that are trying to assess group policy, because if you're not using GPMC, you have to sort of write it all from scratch. All of these tools have taken that on. You don't need GPMC running. It doesn't use any of the GPMC libraries. That's super handy because you can drop these tools on any machine and execute them effectively against your group policy environment. Let me shift gears and just show you how Grouper 2 works. It's pretty straightforward. I'm just going to run it as is, and I'm going to run it in pretty mode, quote unquote. And it's going out and munching through your group policies, and then it starts basically showing all of the, as I mentioned before, all of the kind of different parameters of things that it's looking for, and then the interest level. So NT services, there's some immediate tasks in here. I won't go through the whole thing because it's a little bit hard to read on the screen like this, but essentially what it's doing is looking for anything that's interesting from a security perspective and dumping it out to this report. And that includes, I'll talk about this in a little bit, but it includes permissions on GPOs, linking, settings that might be interesting, like security settings, local group membership, all of that. Okay. So let's talk about attacking group policy now. Actually, before I do that, I meant to show you one other thing that I'm getting ready to, in the next couple of months. So I built this group policy SDK many years ago for reading and writing GPO settings. One of the challenges that tools like Grouper 2 have, or any of these tools, are that if you're trying to determine settings in a group policy object that exist, there is no API for that. Especially without GPMC, you can't run a settings report like you can in GPMC. It's just reading the raw storage files and then trying to parse them to make sense of them. And that's super time consuming. I went through that ordeal many years ago to write this SDK. And I've been working on decoupling the read part of the SDK. There's a getter part and a setter part where you can actually write settings to group policy objects. It also doesn't use GPMC, so the reader part I'm decoupling and making available in GitHub on my GitHub account as soon as I can get the code cleaned up and all the swear words against Microsoft taken out. But I wanted to just kind of show you a little bit about how it works. The first line here, if you can see this, gets a reference to a particular GPO. The second line gets a reference to a setting path, and you can see here that you're allowed to, or you can use this by just referring to the English language setting path as it appears in GP Editor. That's kind of the powerful part about it. You don't have to parse XML or parse some weird INF file. You can just refer to the setting path. You can find out if it's defined or not for a given setting. And this particular line is just looking for who has debug programs, who has been granted debug programs user rights in this GPO, right? And then if I find one that's set to 1, in other words, it's defined, then I want to see what the value of that is. So if I come down here, let me just, well, I'm just going to paste it into PowerShell because it's easier. And if I just run it, you'll see here that it's returned the group that's been granted debug programs right in that GPO, in that setting path. So super easy way of querying GPOs without GPMC programmatically from the command line. You can use it as the underlying code is you can use it in C# or PowerShell. It doesn't really matter. So keep an eye out if you're interested in that. Keep an eye out on my GitHub page that I mentioned earlier. Hopefully that'll be dropping soon. All right, attack paths. So weak write permissions on the GPC or GPT for one or more GPOs. So what's the opportunity here? Writing new settings into a group policy object to execute arbitrary code. So think about all the things that group policy can do. It's like a smorgasbord of execution, right? There's scheduled tasks. There's logon and startup scripts. There's software installation. There's shortcuts. All of these things are stuff that gets sent to the client where the client clicks on something or does something and it executes a code somewhere. And that instruction of where to execute that code is stored in the GPO, right? If it's a shortcut, it's a path to a file. That path can be manipulated, changed, added, whatever. If you have write access to the GPO, you can make arbitrary changes to it. So scheduled tasks is a good example because new GPO immediate task from PowerView. I've actually seen this used in the wild in malware to essentially, once the attacker got into the environment, they used this or something like it to create an immediate task in a GPO that executed on all the machines. And what did the immediate task do? It installed the malware on every machine that processed the GPO. And you can multiply that. The only limiter to that today is the complexity of writing to setting storage. Because if you'll recall, I said that the GPT, where settings are stored, every policy area has not every, but almost every policy area has a different storage format for expressing settings. So if I'm doing user rights assignment or security options, it's in a file called gpt-temple.inf. If I'm doing GP preferences shortcuts, it's in an XML file. If I'm doing GP preferences scheduled tasks, it's in a different XML file with a different schema and a different set of attributes. Every single one. I mean, Microsoft did us a favor here. It's really hard to write an SDK, a unified SDK to write settings into a GPO programmatically. It's hard. And I can't tell you the pain and suffering that I went through to do it over a number of years, and I'm still working on it, but it's not an easy task. But if you have a very defined target, like scheduled tasks, like logon or startup scripts, like security hardening settings, then the task is a lot easier if you're just going after a few of those setting areas. So what are the challenges to doing this? You'll remember I talked about those GPC extension GUIDs that have to be in a GPO for each policy area that's implemented in that GPO. So here's an example. I'm an attacker, I'm in the environment, I'm running new GPO immediate task, and I poke an XML file with the task into a GPO that doesn't have scheduled tasks defined in it. Well, unless I'm also poking into the AD part of that GPO, the GUIDs for scheduled tasks, the clients are just going to ignore it. They don't care. So as an attacker, I have to find a GPO that already has scheduled tasks added to it and add my arbitrary execution code into that GPO storage. Does that make sense? So the process of doing this is, A, I need write permissions on the GPT. I don't even need to touch the GPC. If I'm an attacker, all I care about is that the GPT gives me write permissions. I've got write permissions. I'm trying to write a scheduled task. I need to find GPOs that are linked to targets that I care about. In other words, you want to find a GPO that's linked to as many clients or users as possible. Right? So you probably want to find one linked at the domain level. GPOs linked at the domain level are processed by every computer and every user by default in the domain. So I want to find a good target GPO that has scheduled tasks implemented in it already, and then I can push my XML into the GPT. Great. But that's a challenge, right? It reduces the opportunity. So for new policy areas, if I want to be able to write a new policy area, I have to have permissions to write to the GPC, the AD part of it. I need to be able to add those extension GUIDs to the GPC. And again, as I mentioned, if you're only modifying the GPT, if I'm only writing that scheduled task to the GPT part of the GPO, and I'm not touching the version number in AD, then the clients, it may be a while before the clients know about that. They may not pick it up. So if I'm an impatient attacker, it might not get me where I need to be. Now, you can touch the version number on the GPC if you have write permissions on it and increment it, say, by 1. And then the client will say, oh, something's changed, pick it up, let's go. So weak write permissions on containers. So this is the ability to link and unlink arbitrary GPOs to target users and computers. So let's say I have a GPO that I created because I was able to get privileged access on a user account that had the ability to create GPOs. So I created a malicious GPO. It doesn't do anything just sitting there. I have to link it to something. The next thing I want is write permissions on container objects, OUs, domains, sites, so that I can link my malicious GPO to as many targets as possible. So that's the piece that, kind of, if I have both creation, editing rights on a GPO, and I can link to one or more containers, all bets are off. I can do whatever I want. Including, if I can link that GPO to the domain controller's OU or the domain, there's a neat little, not very well documented feature in restricted groups policy. Remember, I was using restricted groups policy to grant admin access on my machines. You can target domain groups with restricted groups policy. Microsoft doesn't recommend it. I don't recommend it. But let's say I've gotten into the environment. I've created a group or a user account. I can create a restricted groups policy that says put that user account or group into local administrators. And I link that to the default domain controllers, or the domain controller's OU, or even the domain. And what happens? When the domain controller processes it, it says, oh, I need to add this user or group to administrators. Well, the only administrators I know about is the one in AD. So it puts that user and group or group into the administrator's group, in AD. And you're now, you've gone from just a lowly regular person to a domain administrator. OK, pretty much talked about what you can do with linking and unlinking. It works well. It works the same way for unlinking. If I can unlink hardening, then I can weaken the security posture of the organization. So it's just as bad to be able to change links to unlink as it is to create links. Just going to drop out of here for a second to just show what I'm talking about with links. I apologize, I got a little tickle in my throat. So if I'm on an OU, let's say I'm on this client's OU. If I look at the properties of the OU itself, you'll see that marketing admins has been added to the delegation of this OU. And I think this is the one that I mucked with. If I come down here to the permissions on marketing admins and go down to the permissions on the property, what you'll notice is I have write GP options, and on the other ace right next to it, I have write GP link. That is the permission I need to be able to link and unlink a GPO on that OU. So if any user or computer or group or whatever has the ability to write to GP link, I can link a GPO to that OU. OK. All right, so what are the challenges? Well, you need to find existing GPOs that suit your purposes. Let's say you have link permissions, but you don't have permissions to edit GPOs. that's okay. You can use tools like PowerView to find interesting GPOs that grant admin access or do something, from a settings perspective that is advantageous to your position. And then you can use those existing GPOs to link to containers where maybe you have a user account that you've already compromised. External paths. This is one I just wrote up in the past 4 or 5 months. So you have GPOs and the permissions on the GPOs that may not grant write access. But in the GPO, you're referencing external storage locations, like logon scripts that point to a server share somewhere, or shortcuts that point to a server share somewhere. Printers, files where you're copying files from one location to another. All of these can contain external references, paths to servers that are not in sysvol. So even if your GPOs are completely locked down and you can't, an attacker can't write to them easily, if they can get to the server where you have the logon script stored and they have write access to that, doesn't matter. They've just essentially put whatever script they wanted in place of the script that the GPO is referencing, and they can do whatever they want in that script. So you have to think about hardening not only the GPO, but any external paths that it calls. And Grouper 2 looks for that in GPOs that you have. I mean, a part of this is about discovery. In a reasonable size organization, you might have hundreds of GPOs. I had one customer that had 10,000 GPOs. Not fun. So imagine having to go through that and find out all these nooks and crannies. Now the challenge, of course, in this is you still have to have access to those external servers that are being referenced by the GPOs. Okay, I'm going to try to zoom through because I know we're running out of time. GPT redirection. Let's say I have write permissions on the GPC, the AD side of the GPO. When I showed the AD side of the GPO, I brought up the attribute editor. Let me just... And there's an attribute in the attribute editor called GPC file sys path. This is where it tells the GPO where to find the GPT, the sysvol folder. Guess what? I can change this to any UNC path. And that's what this particular attack is all about. If I can make that change, I can redirect it to some server, some SMB share somewhere with a copy of the GPO settings with some alterations that I made for my benefit. And so when the client processes group policy, they will pull this down from this external share happily without thinking about it. Now, when I first published this, a guy in Germany, tag null DE, did some work on it and found that using this technique, he stood up an in-packet SMB server to be the external share and watched the hashes rain in as clients and users were accessing group policy, so NTLM hashes. So it wasn't like universal because there were certain circumstances where you were only getting the computer hashes, but that can be valuable as well. So the point is, there's other things that you can do with this besides just, faking setting storage. So it's really important to be able to control who can write to that GPC in this scenario. Now doing this, the downside to this is if you're an attacker doing this and the admin tries to go in and edit the GPO that you've redirected or report against it, it will just barf all over the place. Microsoft doesn't know what to do with it. So that's a pretty telltale sign that something's wrong. This next one, I just wrote about this. It's a little bit of, it's kind of out there, but I thought it was worth documenting. So admin template settings use something called ADMX files. ADMX files define the text that you see in the GP editor under admin templates and behind the scenes what registry keys and values they write to. Most shops have something called a central store. The central store is just a folder in sysvol where you keep all of your ADMX files, and everyone using GPMC and GPEditor in the domain will use that copy of ADMX files. It's a centralized version control system, if you will, for ADMX, because ADMX files change with every new release of Windows that Microsoft comes out with. So that's kind of the authoritative source. If I have write access to the central store, I can go into it, go into an ADMX file, and change the underlying registry key and value for a particular policy. Now, that in and of itself is not terribly interesting, because in order for that to take effect, an admin would have to come in and set that value after I made that change. So the chances of that are small, of course. I had recommended that if you were going to try to do this as an attacker, that you pick a setting that many shops implement. And I did that here in an example that I have, where I took this setting here, always wait for the network at computer startup and log on, which, I don't know, it's got to be one of the most common settings I've seen in group policy land. And I took the snippet of ADMX file that implements that, so it tells it what registry key and value to write to, and I modified it. And I said, well, actually, if they enable that setting, what I really want you to do is disable UAC. And the text description in GPEditor doesn't change, because that's coming from a different file that's the language independent file called the ADML file. But if they hit this and say enabled, I said, OK, set enable Lua, which is the UAC registry key for enabling UAC. Set it to 0. Turn it off. So suddenly UAC gets turned off on any clients that process that GPO. So again, there's some caveats in terms of leveraging this, because you have to wait for the admin. You really have to be patient. You have to wait for the admin to edit and create use this setting in a GPO. But nonetheless, it's completely hidden. You'll never find it. As an admin, you probably won't find it until it's too late. And there are other things you can do with this as well. I picked an obvious one. Weak write permissions on starter GPOs. This one was kind of a low-hanging fruit thing. I don't know very many shops that use starter GPOs. There was this kind of aborted idea that Microsoft had around creating GPO templates. They never really took it very far. Today it exists to, essentially you can use it to create a template of admin template settings, and then you can create a new GPO from it. Well, just like there's issues with weak write permissions on regular GPOs, starter GPOs have the same problem. If I can write to a starter GPO and write some arbitrary setting in there that maybe weakens security in the environment, like I can write Windows firewall settings into registry.pol, then if somebody creates a new GPO from that starter GPO, then all bets are off. All right, I want to talk a little bit about defense before I run out of time. So as it may be obvious to you, there's probably a couple different things that you can do from a reconnaissance perspective. This first one's a little tongue-in-cheek, but it's actually not a bad way to go. If you're using group policy today for security hardening, stop. Use something else. There's other technologies out there for pushing security configuration to Windows. The second one is more measured, I would say, which is to reduce the visibility of GPOs responsible for security. So don't give the attacker a roadmap to your security posture. If you have GPOs that implement security hardening standards, take away authenticated users' read from the security filtering on that GPO. At the very least, target it to domain computers. What does that do? It means that users, because authenticated users, remember, includes both computer accounts and user accounts. If you're not using authenticated users, you're just using domain computers, then only computer accounts can read the policy, and admins, of course, but a regular user cannot. I have to stop. Let me just talk quickly about hardening. Checklist. Check. Who can write to GPOs? Who can write GPO links? Who can write to the central store? Are the GPC and GPT permissions consistent? Do parent folders and containers in those two grant child rights that are disparate or separate from your GPO delegation? I've seen that happen a lot of times. And external path permissions should match the reference GPOs. Sorry for that last-minute flurry, but hopefully that was useful. Thank you. I don't know. I guess we don't have any time for questions, or?
If you have any questions, yeah. Thank you very much, Darren.